Okay, so today we're going to do two sections, 7.1 and 7.2. The first part, 7.1, should look like a review from Algebra 1 because it's all on proportions. Okay, so let's start off with a ratio. Ratio is just a comparison of two quantities using division. So remember the line, right, means division, a ratio, A to B. You can also use a colon. All right. And then anytime where you have a ratio where the denominator is 1, this is called a unit ratio. Okay, the ratio of football players to high schools in Montgomery County is 546 to 26. What is the ratio of football players to high school written as a unit ratio? So we have 546 players to 26 high schools. So we're going to use our calculator. So hopefully have your calculators ready for this lesson. You will need it. So we're going to divide. And we get 21 players per high school. So that would be a unit ratio. All right. In a triangle, the ratio of the measures of three sides is 4 to 6 to 9. And its perimeter is 190 inches. Find the measures of the three sides of the triangle. So here we have a triangle. We don't know the actual side measures. We just know 4 to 6 to 9. So what we're going to do is we're going to rewrite these as 4x to 6x to 9x because we need a common factor between the three of them. So perimeter is 190, and we know when we're finding the perimeter of a triangle, we're going to add those together. So 4x plus 6x plus 9x, which works out nicely. We get 19x equals 190. So x equals 10. So that's the common factor between the three of them. So what are the measures of the three sides? And we do have units here. These are sides. So this is inches. 60 inches, and 90 inches. Okay, the next one, the ratio of the three angles is 2 to 3 to 5. Find the measures of the angles. We're going to do something similar. We're going to make a common factor of x. Now this time we're referring to the angles. So we have a 2x, a 3x, and a 5x. These go inside. And we know three angles always have to add up to 180. So we add these all together, we get 10x equals 180. So x equals 18. What are the measures of the angles? So we have 36, we have 54, and we have 90. Okay, those are ratios. Now we're going to turn it over to proportions. So proportions are basically an equation where two ratios are equal. And sometimes we're missing a measurement, so we have to do what are called cross products, or you might know it as cross multiplication. Okay, so we're going to jump down here. Property of proportions. If you have A over B equals C over D, we get to cross multiply. So we have AD equals B times C. All right, let's solve the proportions. So we're going to multiply. And it doesn't matter which side you multiply first. So we get 5x equals 3 times 75. So 3 times 75 is 225. Then we divide both sides by 5. And we get 45. All right, same thing over here. Again, it doesn't matter which sides you multiply first. So 2 times 3x minus 5 equals 4 times negative 13. So don't forget to distribute here. 6x minus 10 equals negative 52. We're going to add 10, so that gives us negative 42. Divide both sides by 6, and we get negative 7. If you want to pause it and try the next one on your own, that's not a bad idea. So I have x minus 1 times x plus 2 equals 2 times 5. Now on the left side, I have to do FOIL. We have to multiply it out. So it's going to be x squared plus 2x minus x minus 2 equals 10. Or x squared plus x minus 2 equals 10. We have a quadratic, which means we have to get everything on the same side. So I'm going to subtract 10. So that's going to make that a minus 12. Now I'm thinking two numbers that multiply together to give us negative 12 and add up to 1. So I'm going to have a plus 4 and a minus 3. So I get x equals negative 4 and positive 3. Now, because these are just proportions and we're not referring to the length of sides or the angle measures, it's completely fine to have a negative number. All right, let's see on the next one. Again, if you want to pause it and then see if you get the same answer, go for it. So we have 2x plus 5 times x minus 1 equals x plus 3 times x plus 4. Again, we're going to FOIL. So we get 2x squared minus 2x plus 5x minus 5 equals x squared plus 4x plus 3x plus 12. Let's combine like terms. So we have 2x squared plus 3x minus 5 equals x squared plus 7x plus 12. All right, I want to move everything. Again, since I have a squared, I want to move everything to the same side. So I'm going to move everything on the left over to the right. So that's going to give us x squared minus 4x minus 17 equals 0. Okay, so the problem we have here is this is not going to factor. Okay, so we have to look at the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So I get 4 plus or minus, so 4 squared is 16 minus 4 times a, which is 1, times c, which is negative 17, all over 2 times a. All right, let's see how that simplifies. So that's going to become 16 plus 4 times 17 because that's a positive there. So that's going to be square root of 84 over 2. Now 84 we can simplify to 2 root 21. And then I can reduce that even further. So it'll just be 2 plus or minus root 21. Okay, which leads us into 7.2. This is going to be the geometry portion, looking at similar polygons. So we've done congruent polygons where they have to have the same size and the same shape. Similar polygons have the same shape, but not necessarily the same side. So corresponding angles always have to be congruent, but the corresponding sides are proportional, meaning they have to have the same ratio. So here's an example of two similar polygons. So we look at each angle. A and W are congruent. B and X are congruent. C and Y are congruent. And D and Z are congruent. So they have to be congruent. But when we look at the sides, they are not equal. They are proportional. So if I'm comparing 15 and 5, right, I get 3 to 1. If I compare 12 to 4, that also reduces to 3 over 1. If I compare 21 to 7, that also reduces to 3 over 1. And 18 over 6, also 3 over 1. So they have to all have that same ratio. If one of them turns out to be different, you do not have similar polygons. Okay, so the symbol So just like that squiggly line over the congruent, right? So without the equal to part is similar. So the statement of similarity would be ABCD similar to WXYZ. Again, the order is really important. So we want to make sure that the corresponding angles and the corresponding sides match up. Scale factor. So the ratio of the lengths of corresponding sides is called the scale factor. So what would the scale factor be from the quadrilateral ABCD to WXYZ above? That would be a ratio of 3 to 1. You can write it as a fraction or with the colon, it doesn't matter, but you do need to have the 1, okay? Scale factor is a ratio, so you need to have 2 numbers. You can't just write 3. All right, let's determine whether the pair of polygons is similar. So first we look at angles. Yeah, so angle A is congruent to angle E, right? Angle B is congruent to angle F. Angle C is congruent to angle G, and angle D congruent to angle H. So all the angles are congruent. Now let's check, are the sides proportional? So let's check 4 to 6. Okay, so that will reduce to 2 to 3. Well, obviously, looks like this is a parallelogram because opposite sides are congruent. So far we have 2 sides that have the same ratio. Now let's check 3 to 9 halves. Okay, so here we have a complex fraction. So if we have 3 divided by 9 halves, that's like saying 3 over 1 times the reciprocal 2 over 9, which we can reduce, and we do get 2/3. Check. Last one, 3 to 9 halves. Well, we just did that. We know that's going to be 2/3. So since all the corresponding sides end up having the same ratio, yes, they are similar. Let's check the next one. Okay, so just looking at all the angles, we can see that they're congruent. So I'm just going to write all corresponding angles are congruent. So that's check. Now let's check to see the sides. So let's see. 12 to 6 ends up being 2 to 1. 10 to 5. 2 to 1. Good so far. 7 to 3.5. Yeah, 3.5 goes into 7 twice. Good. And lastly, 6 to 3 ends up giving us a 2 to 1 ratio. So yes, they are similar. Okay, each pair of polygons are similar. So they're telling us that they're similar. We want to write a similarity statement, find x, and measure of the indicated sides and the scale factor. Scale factor of the one on the left to the one on the right. So it's important what order we put it in. Okay, let's start off with a similarity statement. So the first one, we could name this any way we want. I'll just go with A, B, C. We're going to use a similar, not congruent. And then we want to make sure it goes in order. So D matches with A, E matches with B, F and C. All right. Scale factor. So we want to compare 2 sides that are corresponding. So the only 2 sides that I know that are corresponding are the 27 and the 18. So if I do 27 over 18, and then let's reduce that. So 9 goes into 27, 3. So 3 to 2. Now, I can make a proportion to solve for x, and there's lots of different ways I could set this up. I could do 21 over x equals 27 over 18. But again, 27 or 18, that was the scale factor. So sometimes it's easier just to use the scale factor when we are simplifying this. So let's cross multiply. And 3 goes into 42 14 times. And df is x, so that is 14. Let's look at the next one, similarity statement. Now be careful on this one, everything is kind of turned around. So let's name the first one. And since this is a quadrilateral and it's definitely not a parallelogram, I'm not going to put any symbol in front of it. I'm just going to do A, B, C, D, similar to, so A matches with E, B matches with F, and it does just go in alphabetical order, G and then H. Okay, scale factor. Okay, we have a situation here where we don't have enough information to find the scale factor because I don't have any measurements in the polygon to the right. So what I'm going to have to do is I'm going to have to solve for x first, and then we can go back and find scale factor. So I'm going to work with, let's see what sides are matching. So let's see. FE or EF is x plus 5. So again, you can go back to the order of the letters if you need. EF is the same as AB. Remember, this is all turned around. So x plus 5 corresponds to 14. And then let's see, x minus 3, HE, corresponds to AD, which is 10. And now we want to cross multiply. So I have 14 times x minus 3 equals 10 times x plus 5. Let's distribute. And we get 4x equals 92. And then we're going to divide. So we get x equals 23. Now, if x equals 23, that's going to make HE 20. And it's going to make FE 28. So we have 28 here. This is 20. And then we have to find GF, which we don't know anything about. But remember, now that we have two of our sides, we can find the scale factor. So let's take, for example, AB is 14. That corresponds to EF, which is 28. So that gives us a scale factor of 1 to 2. So that means if BC is 16, and I'll call this we'll call it W just to have a different variable. So if the scale factor is 1 to 2, W has to be 32. All right, similar polygons have similar perimeters, or meaning their perimeters are proportional to the scale factor between them. So let's take a look at the two polygons below that are given are similar. Let's solve for x and for y. So let's see. Okay, I know 6 and 4. So 6 is to 4 as x is to 3, or you could do 4 over 6 and 3 over x, right? It doesn't really matter as long as you make sure that the corresponding sides are matching. Let's cross multiply. And we get 18 over 4, or 9 over 2. Let's do the same thing, but let's do y. So maybe this time I'll do 4 over 6. So 4 over 6 equals y plus 1 over 8. So let's cross multiply. 6y plus 6 over 32. 6y equals 26. And we get y equals 13/3. What is the scale factor between the perimeters? Well, all we need to do is and we're comparing RSTUV to ABCD. So again, scale factor is just comparing two sides. So if I'm doing this smaller one on top to the bigger one, that would be 4 to 6, which reduces to 2 to 3. Our last example, we have triangle JKL similar to TUV with a scale factor of 3 to 4. Okay, so I'm just going to I'll draw a JKL, and I'll just make one a little bit bigger. It doesn't have to be perfect. TUV. All right, so the scale factor is 3 to 4. If the length of the sides of TUV are 4, 6, and 8, what are the lengths of the sides of JKL? So, well, I don't know what any of these are. I'll just call them X, Y, and Z. So if the ratio is 3 to 4, so X over 4 equals 3 over 4, right? So, and we know Y over 6 equals 3 over 4. And we know Z to 8 is also 3 to 4. All of those have the same ratio. So we can just cross multiply, or in this case, we can see X just has to be equal to 3. Or let me rewrite that. Actually, we'll just leave it like that. X equals 3. 4Y equals 18. So that's 9 over 2. And lastly, we have 4Z equals 24. So Z equals 6. So 3, 9 halves, and 6 are the 3 sides. Okay, and you can start working on the 7.1 to 7.2 homework for tonight.